The mysterious lights of Proxima Centauri b. The James Webb Space Telescope has captured something truly extraordinary, something that might change how we see our place in the cosmos. Faint, flickering lights have been detected coming from Proxima Centauri b, a planet located just over 4 light-years away from Earth. These lights are unlike anything we've seen before. They don't appear to be natural reflections or flares. Instead, they resemble the glow of artificial city lights shimmering steadily in the darkness of space. This remarkable observation has reignited an age-old question that continues to captivate humanity. Are we truly alone in the universe? Scientists all over the world are now buzzing with curiosity and speculation. Could these lights be evidence of an alien civilization? Are we finally glimpsing signs of intelligent life beyond our solar system? The James Webb Space Telescope, equipped with state-of-the-art infrared sensors, has been monitoring the nearest exoplanets to Earth. Among them, Proxima Centauri b stands out not only because it's the closest exoplanet, but also because it lies within the so-called habitable zone of its star. This means it's at just the right distance for liquid water to potentially exist on its surface, a key ingredient for life as we know it. While scanning the planet, the telescope picked up bursts of light from its dark side. These glimmers, measured over time, revealed a pattern that strongly suggests they're not caused by natural geological or atmospheric processes. The flickers are too regular, too steady. And their wavelength distribution is oddly narrow, resembling the kind of spectrum that artificial light sources emit. The idea that we might be observing city-like lights from another planet may sound like science fiction, but for many astronomers, it's a hypothesis worth exploring. Because even if these lights aren't from alien cities, they may still signal something incredible, perhaps geothermal activity, technological emissions, or unknown natural phenomena yet to be discovered. David Kipping, an astronomer at Columbia University, commented that Proxima b is a particularly complex planet. Unlike typical rocky planets that merely absorb sunlight and emit heat, Proxima b seems to behave differently. Its orbit around the red dwarf star Proxima Centauri causes it to experience extreme variations in temperature. If Proxima b lacks an atmosphere, these changes could be dramatic. The day side might heat up under intense solar radiation, while the night side could plunge to freezing sub-zero temperatures. But if an atmosphere is present, it might distribute heat more evenly, creating a more stable environment that could potentially support life. This is where the infrared sensitivity of the James Webb Space Telescope becomes a game-changer. Unlike visible light telescopes, James Webb can detect heat signatures and thermal emissions, even from the dark side of a planet. This allows scientists to measure how temperatures shift between day and night and determine whether an atmosphere might exist. Interestingly, Proxima b completes an orbit around its host star every 11.2 Earth days. This relatively short orbital period provides astronomers with regular observational windows. With each pass, the telescope gathers more data, helping researchers build a clearer picture of the planet's climate, structure, and energy patterns. If Proxima b truly has an atmosphere, the next step will be to study its chemical composition. Scientists will be looking for telltale signs of life: the presence of oxygen, methane, carbon dioxide, and especially water vapor. Each of these elements, if detected in the right ratios, could indicate that biological processes are taking place. But that journey is just beginning, and peering deeper into alien worlds, the future of exoplanet exploration with the tantalizing discovery of mysterious lights on Proxima Centauri b, our understanding of the universe has entered a thrilling new phase. The question has now shifted from, could life exist out there, to, how do we confirm it, and what tools will help us get there? This is where the future of space exploration takes center stage. While the James Webb Space Telescope has offered groundbreaking insight, it has its limitations. It's designed primarily to observe in the infrared spectrum, making it perfect for detecting heat patterns and atmospheric gases, but only from a handful of exoplanets relatively close to Earth. To truly dive deeper into alien worlds, to study them with precision, and maybe even directly observe them, we need something bigger, sharper, and more powerful. Enter the Extremely Large Telescope, or ELT. Scheduled to begin operations in 2028, This next-generation ground-based observatory will revolutionize the way we view the cosmos. With a massive 39-meter primary mirror nearly half the size of a football field, the ELT will collect more light than any optical telescope ever built. This means it can study planets that are fainter, further, and smaller than anything we've been able to see so far. The ELT won't just look at stars, it will dissect the atmospheres of distant exoplanets, pixel by pixel, spectrum by spectrum. Using a technique called high-resolution spectroscopy, it will detect subtle chemical signatures, measuring the presence of gases like carbon dioxide, oxygen, water vapor, and methane. These gases, especially when found together, can be strong indicators of possible biological activity. However, there's one major hurdle when observing exoplanets. Their stars are just too bright. Even the nearest stars outshine their planets by factors of millions or billions, making the reflected planetary light nearly impossible to isolate. It's like trying to see a firefly circling a stadium floodlight from across the street. To solve this, astronomers are developing breakthrough technologies designed to block out that overpowering starlight. One such tool is the coronagraph, which is integrated directly into a telescope's optics. This device carefully suppresses a star's glare, allowing astronomers to mask the bright light and focus only on the dim signal of the planet next to it. Using coronagraphs, telescopes like James Webb and future missions can spot planets that were previously invisible. But an even more ambitious solution is the Starshade, a massive, flower-shaped spacecraft designed to work in tandem with a space telescope. Positioned tens of thousands of kilometers in front of the telescope, the Starshade creates a perfectly shaped shadow that blocks the star's light before it even reaches the telescope. This allows only the faint light from the surrounding planets to pass through, giving us an incredibly clean view of distant worlds. The precision required to align a starshade is staggering. It must stay in perfect position relative to the telescope, adjusting over vast distances with micrometer accuracy. It's an engineering challenge unlike anything ever attempted in space, but one that could change the course of astronomy forever. Once the faint light of a planet is captured, astronomers use spectral analysis to break it down into its basic components. Different molecules absorb light at specific wavelengths, allowing scientists to determine exactly what a planet's atmosphere contains. The presence of oxygen, ozone, methane, or even chlorophyll-like signatures could point toward active, life-sustaining processes. And these techniques won't just tell us what's in the air, they could eventually reveal features on the surface of distant planets. With the help of adaptive optics, which correct for the distortions caused by a planet's atmosphere or by the telescope's motion, we could one day generate highly detailed images of exoplanets. Imagine being able to observe seasonal changes, cloud patterns, or even vegetation cycles on a world orbiting a star light-years away. Some future space missions even envision entire fleets of telescopes working together, sharing data, combining imaging power, and coordinating to produce full-spectrum portraits of alien worlds. In theory, this could lead to 3D maps of exoplanets, complete with terrain, weather systems, and long-term climate monitoring. Of course, all of this is still developing. The path forward will require time, funding, technological breakthroughs, and international cooperation. But the payoff? It's nothing short of redefining humanity's place in the universe. Whether the lights seen on Proxima Centauri b are artificial or natural, they have cracked open a new window of possibility. They remind us that the universe is vast, full of mystery, and possibly full of neighbors we've yet to meet. We are on the edge of a new era, one where science fiction meets real data, and where dreams of contact might finally become reality. The search for extraterrestrial life is no longer a fringe curiosity. It's one of the most compelling and active areas of science today. Thanks to trailblazing instruments like the James Webb Space Telescope, the upcoming ELT, and the advanced technology behind coronagraphs and starshades, we are closer than ever to answering the question: are we truly alone in the cosmos, or is someone else out there watching the stars, just like we are? Let us know what you think in the comments section below. If you found this journey fascinating, be sure to like, subscribe, and tap the notification bell so you don't miss the latest updates.